Welcome everyone. Thank you for joining us for our first forestry speed dating webinar focused on extreme wildfire events. This is a collaboration of the Bioregions Facility and the FireS project. I'm Sibe Briers, I'm an expert at the European Forest Institute's Bioregions Facility, and I'm happy to moderate today's webinar. In recent years, Europe has experienced a record number of extreme wildfire events, leading to the burning of over 500,000 hectares in the EU alone in 2023, and also 20 megatons of carbon dioxide emitted into the atmosphere. To respond to these challenges, we need solutions that efficiently and effectively address wildfire risk in Europe and beyond. Therefore, the Forestry Speed Dating series serves as a platform to promote innovative solutions, fostering innovation and catalyzing collaboration in the forest bioeconomy. This Forestry Speed Dating wouldn't be possible without the great support of the Bioregions Facility member regions. These are the Basque Country, Catalonia, and North Rhine-Westphalia. I invite you all to learn more about our member regions on our website. Now, this series is a collaboration with the FireS project. FireS is a Horizon project focused on enhancing wildfire resilience by developing and implementing innovative solutions. It brings together different organizations, experts, and stakeholders to address the challenges of extreme wildfire events. Now, in today's session, let's deep dive into 3 innovative solutions from Germany, Spain, and the UK.
Very much. So my name is Martin, and together with David, a fellow wildland firefighter, we created HoZe Solutions as a consultancy company in order to find solutions to some of the problems that we've seen during wildfire incidents, mainly in Southern Europe, with most of our time spent in Greece during summertime. And we've built this company with a vision of creating wildfire resilient landscapes. And so that is in a big part due to the fact that when we have a wildfire developing, and especially with today's context of extreme wildfires, this landscape is made of a variety of asset owners, which share different features, different sizes, from homeowners, industrial sites, all over to public land. And so we wanted to create a tool that allows all these different asset owners to prepare for a wildfire season. And so one of the first tools that we've been looking at is essentially best practices. And the key best practice that we want to see implemented in those landscapes is defensible space. Which is a very simple approach when you think about it. It's a different radii drawn around an asset in which different criteria need to be fulfilled in order to reduce the risk for an asset and in order to improve firefighting operations. Now, the uptake of those best practices is somewhat slow, and it's in some part due to the fact that it's difficult to visualize where or how these defensible spaces look like. And so the first tool that we're working on is essentially a visualization tool that allows us to display the defensible space around an asset and understand risk drivers that are present within that defensible space. And so this is a tool that we want to make available to any asset owner in wildland urban interfaces so that they can identify risk and find ways to mitigate that risk. So the way we're working is we're offering access to this tool freely, and in case there is interest, in case there are risk drivers identified in that defensible space, then we're offering risk mitigation services. In essence, we're looking at the easiest way to reduce the risk and compile this into a risk mitigation report. France and Greece are currently issuing laws that are anyway enforcing people to hand in such reports. We believe this is a very good initiative, and we hope that we can see this all over Europe. Now, in some of the cases, best practices won't be sufficient if there's safety aspects, if there's decorative aspects. And so for all critical infrastructure that requires additional safety layers, we're also looking into fire protection systems. And so this is something that I'll be talking more about in just a second. What I want to say right now is that we've spent quite a lot of time in learning more about the fundamentals of fire during the development of our product, so that as a unique selling proposition, we can boast the use of proprietary data sets that we gain during experimental fires to help us understand which mitigation strategy works best. We have these digital tools that aren't currently available, and we're using state-of-the-art technology to automate these processes so as to make them fastest. When I say we, so as I mentioned, there's David and myself. We know each other for more than 10 years, having spent most of the time together during wildfires in Greece. David's background is in business management. My background is in engineering, holding a PhD from ETH Zurich. And we're currently part of the Business Incubation Center of the European Space Agency in Germany. And we're also part of the Open Innovation Challenge that was initiated by FireRes. And more specifically, what we're doing within FireRes is looking at the use of this autonomous containment system. Our learnings from fighting fires is that we currently have a very inefficient use of water, be it from aerial drops or when using trucks. So we created a system that creates an environment through which the fire will have difficulty to progress, or even will be blocked, and therefore we will manage to contain it. The upsides of that system is that it is highly efficient in water usage, and it is autonomous, so that we do not have any practitioners in the risk area. We know this from these experimental fires that we've carried out in Portugal, so that we can put some figures. Typically, we have up to 1,000-fold savings in water. It's easily scalable to kilometer lengths, and it's very simple to maintain. So in case you would be interested in seeing this hardware solution installed and tested, or in case you are managing assets that are at the risk of wildfires and you are looking for ways to mitigate risk, we'd be more than happy to get to know you and exchange about the solutions that we're offering. Thank you very much.
First of all, I would like to thank this webinar organizer for inviting us and for giving us the opportunity to share our proposal with you. This proposal that I'm going to present today is called Mosaico, and it's a tool designed to prevent mega wildfires by creating landscapes and communities more resilient to the severe effects of this new fire. So Mosaico is coordinated by the professor, the Dr. Fernando Pulido, and our team from the University of Extremadura, and it's based on over 7 years of development and experience. Actually, this idea started to be developed after a large wildfire in 2015 in Sierra Legata in the northern Extremadura. And this fire made a social movement emerge, criticizing the way fires were being handled in that time. And it was when the University of Extremadura started to direct and offer providing new solutions and new alternatives for fire prevention, supported by our regional administration. So Mosaico is based on the concept of fire smart landscape or fire smart territory. Even though this concept is of fire smart territory is still not fully defined, our approach is linked to proactive prevention, understanding proactive prevention as a participatory strategy which involves local people working together toward a common goal. And this case is reducing the fire risk of the territory. But how do we reduce the fire risk? By applying the same and the basic principle of traditional prevention, which is reducing the fuel load. The difference here is how we achieve this goal. In our case, we aim for a holistic and participatory land management, which integrates agriculture, livestock, or forestry traditional practices to create a mosaic landscape which is able to break up the continuity of the field. So is pretty simple to understand because nowadays, as you know, in many Mediterranean countries, we are suffering the growing challenge of mega wildfires. So the intensity of this new fire is increasing, and it's increasing because of climate change, obviously, but also because of landscape we have. In many mountainous areas of these regions, the rural abandonment and the lack of productive activities have provoked large, continuous, and unmanaged forests. We are highly prone to fires. So to tackle this situation, we need to change our methodologies because it's tested that the only methodology possible to tackle this situation is the management of the fuel. So we need to change the landscape configuration. So at this point, we need to know which actors are the responsible for making this possible. In Mosaico, we involve all local stakeholders connected to the territory and prevention, directly or indirectly, such as landowners, farmers, livestock breeders, beekeepers, resin collectors, NGOs, businesses, or public administration. Because this promotes a sustainable land use and fosters at the same time community engagement through cooperation and association. From a fire behavior perspective, fire spreads slower in this kind of landscapes with fuel model less flammable and with less risk. So our methodology works in fire terms, but it also is so important, boosts socioeconomic revitalization of rural areas which suffer depopulation. Because we can't forget that these new fires are more aggressive in these areas. So nowadays, we have several scientific papers which support and back up our methodology, showing how we can decrease the burn area in large wildfires at the same time that we are increasing the regional climate resilience. So after this theoretical approach, let me show you how this change in landscape configuration actually works to prevent large wildfires. In practice, in Mosaico, we use our basic tool, which are called productive fuel breaks, and I'm going to show you two practical cases to make it clear. As a basic definition, productive fuel break can be considered intervention in high-risk area with the goal of reducing fire risk. This goal is achieved through economic different land uses, livestock, agriculture, forestry, or a combination of them, where maintenance and production help to keep the fuel low and slow the spread of the flame. Additionally, another key benefit which must be highlighted is the fact that the presence of these local farmers in the territory increase forest surveillance at the same time that early fire detection. So we complement our current suppression system. So in this way, productive fuel breaks become a comprehensive solution for large wildfire prevention. All of them create a mosaic pattern landscape which is able to reduce the potential severity of this kind of fire, safeguarding our landscapes and our local communities and resources. So coming back to the slide, to these practical cases, if you can see in the slide, traditional or conventional fire break marked in red, and our productive fuel break marked in blue. In this case, it's an area for goat grazing, and it's located on a strategic area from a fire behavior view. And actually, we started to plan this intervention based on this fact. First, a goat building was designed, and after a local farmer with more than 400 goats was established there. And now he's the person who managed all this area. So it's a clear example of how a productive rate can complement perfectly the traditional one, and it enhances its effectiveness, increasing the area with low or even zero fire risks. And it's so important because now our firefighting bodies can operate there in a safely way. So in this second case, we have a tetanus plantation with a low planting density, but it follows the same principle. It's breaking the continuity of the fuel by changing fuel models to other ones less flammable. And this mosaic pattern landscape is which let us reduce the fire risks in the territory. Unlike other theoretical approaches, Mosaico is a methodology which has been tested, refined, and improved in over 7 years of experience. During this time, we have implemented 120 productive rate in our pilot area in northern Extremadura in the regions of Sierra de Gata and Las Urbes, with more than 6,000 hectares. And all of these results are published in our latest scientific paper that if you are interested, you can have a look. This is in this slide. So what we are offering to the project, to FireRace in this case, is an innovative and a testing methodology with the main strength that Mosaico focus on trying to reduce and mitigate the effect of the root causes of the problem. So also is a participatory movement whose result generate economic, environmental, and social benefits. And additionally, Mosaico has a very high capacity for transference to other regions. And it's so important because with this, we can improve and contrast our results in different scenarios, of course. And I say this because now we are at a stage where additionally to the technical and academic focus, we consider that it's crucial to decision maker, but also business sectors or even general society can see wildfire prevention as an economic opportunity. This is a co-benefit, really. So this Mosaico is approach based on long-term measures with reduced costs and improved efficiency. So to give you a last example, and with this I finish, imagine the execution and the maintenance of a traditional fire breaks. It involves high public costs and its efficiency is limited. So its useful life is 2 or 3 years. In comparison, the maintenance of a productive rate reduce public prevention costs, increase the efficiency of the whole prevention infrastructure, and at the same time, it's generating local economy. So this is the principle of a more resilient community. That's all from my side. Thank you very much. I hope you enjoy the presentation. And if you have any question, or even if you have any consideration, you can send us an email to one of these email accounts that we are glad to reply them. So thank you again.
Hello, I'm Aaron. I'm the CEO of Trigan. So we're building something a little bit different, but in some ways similar to other projects. What we're doing is we're building a system that goes on top of any community in the real world, whether it's a home or office, it could be a street, it could be, you know, a city, region, a country, it could be the whole world. They're necessary communities, funds, ideas, and other resources can flow between them. So the idea here is that this can apply to emergency situations too, through what we call consensus of experts. So in a wildfire situation, you have sensing initially. So for us, that can be done by humans as sensors, or it can be done through third-party IoT sensors. This is to identify as quickly as possible and then to try and solve the issue. So what we do there is we have consensus of experts where experts in their field, say in emergency fire addressment, can allocate resources on the ground with AI support. So we have a technology we developed that takes consensus of local LLMs. So it asks multiple of them for their opinions, and these can be expert too, as in specialist AIs. And these give recommendations to help the on-the-ground firefighting also. So, in a typical fire scenario, you have detection, you have combat, and then you have resolution. So for us, we try to cover the whole thing in a holistic approach through the societal operating system concept. So we have the people as sensors, we have the different ways of addressing a fire. Then post-fire, we have actual rebuilding as projects, because we uniquely digitize projects or work as a thing that can be made to relate to the real world. So that means that a work can be time-based, task-based, or validation work done. So we can break down anything, any kind of transaction or any kind of work into a project of milestones that can be fed back to the system and enacted. So if you think of like how Uber set up a contract between the customer and the driver, we can do that for anything, which is quite a powerful case. So the key parts of what we're building are decisions. We change how decisions are made, because really decisions haven't really changed since the Industrial Revolution. You have a bottleneck, and in an emergency situation, that's not a good thing to have. What we do is we flatten that bottle. We make a thing where these communities can come together and solve things together, but also with expert support. We have resource allocation, which means it can work with anything. It can be funds, it can be cryptocurrency. I mean, it could even be barter. It's a way to say, okay, let's send a helicopter there. Do we have consensus of experts? Yes, go, done. And we also have tasks, which is obviously the contracts, as it were, where people are rewarded for doing work on behalf of the platform. So this is something that could tackle any kind of project. It could be a local park for neighbors. It could be, rebuilding or building a city. It could be urban maintenance, ecological disaster of any sort, vital services anywhere in the world, and so on. There are two co-founders. I'm the conceptual founder and CEO. There's also my wife, who's a medical doctor and social scientist from Azerbaijan. I'm from Scotland, obviously. And we've been in a lot of programs over the past year. I'm currently in Singapore on a Scottish government UK trade mission. So it's sort of a hybrid between the two. And what we're looking for at the moment is we're looking for customers, we're looking for partners, and we're looking for investment. So this is a thing that sits on top of any community, and it helps people to solve problems, whether it's every day or whether it's in an emergency. And the idea is that we don't have so much loss, we save lives, and we have a better world for everyone. Thank you for your time. That's me.